Welcome to Astronomy Daily. I'm excited to bring you another fascinating day of space and astronomy news. There's quite a bit to cover today, from orbital drama to seasonal changes on the red planet. We'll start with a concerning development in Earth orbit, where a retired military weather satellite has broken up into dozens of pieces, adding to a pattern of similar incidents with these particular spacecraft. Then we'll look ahead to SpaceX's upcoming Bandwagon 2 mission, which will carry an impressive array of 30 different payloads into orbit, including an advanced radar satellite for South Korea. We'll also take a journey to Mars, where NASA's Mars Reconnaissance Orbiter has been capturing some incredible seasonal phenomena. Unlike Earth's gentle seasonal transitions, Mars experiences some remarkably explosive changes during its spring thaw, and I can't wait to tell you all about them. Plus, we've got to look at a new theory about that mysterious dark energy, and we'll revisit an age-old debate with some new research. So, let's get started. In a concerning development, the U.S. Space Force has reported that a defunct military weather satellite experienced what they're calling a low-velocity fragmentation event on December 18th. The incident occurred at an altitude of about 840 kilometers, creating more than 50 pieces of trackable debris, according to radar observations from commercial space monitoring company Leo Labs. The satellite in question, known as DMSP-5D2F14, was launched back in 1997 as part of the Defense Meteorological Satellite Program. After serving its purpose for over 2 decades, it was retired in 2020, but remained in its sun's synchronous orbit. Weighing about 750 kilograms, this spacecraft is now the latest in a series of similar satellites to meet this unfortunate fate. What's particularly concerning is that this isn't an isolated incident. Several other satellites from the same family have experienced similar breakups over the years. In October 2016, the F-12 satellite broke apart following the fragmentation of F-13 in February 2015. Going back even further, the F-11 spacecraft created 56 pieces of tracked debris when it broke up in 2004. The root cause appears to be a known design flaw in these satellites' battery assemblies that makes them vulnerable to explosion. This issue isn't limited to military satellites either. Similar civilian weather satellites operated by NOAA have suffered the same fate, with NOAA 16 breaking up in 2015 and NOAA 17 following suit in 2021. Most troubling is that these breakups occurred despite attempts to prevent them through a process called passivation, where satellites are prepared for decommissioning by draining their batteries and venting fuel tanks. Industry experts note that this process may not be fully effective on older satellites that were designed before modern orbital debris mitigation practices were established. Next up, SpaceX is gearing up for an exciting rideshare mission from Vandenberg Space Force Base in California. The Bandwagon 2 mission, scheduled for a 3:34 a.m. Pacific launch on December 21st, will carry an impressive array of 30 different payloads to orbit. The star of this mission is a sophisticated radar satellite for South Korea, capable of seeing through clouds and darkness to capture detailed images of Earth. This spacecraft is part of South Korea's 425 project, a constellation of military Earth observation satellites that combines both optical and radar imaging capabilities. Among the other fascinating payloads are 2 satellites from ICE that will join their radar imaging constellation, and a trio of satellites from Hawkeye 360 that will work together to pinpoint radio frequency transmissions from orbit. 2 compact weather satellites from Tomorrow.io will collect valuable atmospheric data, while LizzieSat-2 will test out new imaging and computing technologies in space. The mission will use Falcon 9 booster B-1071, making its 21st flight. After sending its passengers on their way, the booster will return to land at Landing Zone 4, right next to its launch pad. The second stage will perform a carefully choreographed series of burns to deploy the satellites at 2 different altitudes, most at 510 kilometers, and the South Korean satellite at 570 kilometers. This launch represents SpaceX's 131st Falcon mission of the year, marking an incredibly busy period for the company. It's also their second dedicated rideshare mission to a mid-inclination orbit, specifically chosen to keep these satellites positioned over more populated areas of our planet, rather than following the polar orbits typically used for Earth observation missions. After deployment, these satellites will begin their diverse missions, from Earth imaging and weather monitoring to testing new space technologies and providing communication services. Together, they represent a remarkable snapshot of the increasing variety and capability of small satellites being launched today. Ever thought about the concept of seasons on other planets? While we're celebrating the approaching new year here on Earth, Mars has already completed its journey around the Sun, marking the end of its 687 Earth Day year this past November. But unlike Earth's northern winter wonderland or southern hemisphere's summer, Mars is experiencing a spectacular spring awakening that's far more dramatic than anything we see here at home. Instead of gentle snowmelt and trickling streams, Mars puts on an explosive show. The red planet's thin atmosphere means ice doesn't gradually melt into liquid. It transforms directly into gas in a process called sublimation. This creates some truly remarkable phenomena that NASA's Mars Reconnaissance Orbiter has been tracking for nearly 2 decades. One of the most dramatic events are the frost avalanches. Imagine witnessing a massive chunk of carbon dioxide frost, wider than a house, breaking free and tumbling down Martian cliffs. The orbiter's high-resolution cameras actually captured one of these spectacular events, showing a 66-foot wide block of dry ice in freefall. But that's just the beginning. As spring temperatures rise, pressurized carbon dioxide gas builds up beneath the surface ice until it literally explodes upward, creating powerful geysers that blast dark fans of sand and dust into the Martian sky. These explosive jets leave behind distinctive patterns in the soil that, when viewed from orbit, look remarkably like giant spider legs etched into the surface. Perhaps most impressive is the planet's northern ice cap, a structure as large as Texas that features enormous spiral troughs carved by powerful seasonal winds. Some of these troughs stretch as long as California, dwarfing similar features found in Antarctica. As the spring thaw begins, these channels become superhighways for warm wind gusts that gain speed and heat as they race downhill. These same winds are constantly reshaping Mars's landscape, particularly its sand dunes. During winter, carbon dioxide frost locks these dunes in place, but once spring arrives and the frost sublimates, they begin their slow migration across the Martian surface. It's a seasonal dance that's been ongoing for eons, sculpting and reshaping the face of our neighboring planet. What makes this even more fascinating is that each Martian spring is unique, with subtle variations in temperature and timing creating different patterns of sublimation and surface activity. It's a reminder that Mars, despite its apparent desolation, is a dynamically changing world with its own distinctive seasonal rhythm. Now let's dive into a topic that's been puzzling scientists for decades: dark energy. For years, the term dark energy has been used to describe the mysterious force believed to drive the accelerated expansion of our universe. It's thought to make up about 2/3 of the universe's total mass energy content. However, recent research from the University of Canterbury in Christchurch, New Zealand, challenges this long-standing concept. Led by Professor David Wiltshire, the team analyzed supernova light curves with enhanced precision. Their findings suggest that the universe's expansion isn't uniform, but rather lumpy, varying in different regions. This challenges the conventional lambda cold dark matter model, which relies on dark energy to explain the universe's accelerating expansion. The researchers propose an alternative, the timescape model. This model considers that gravity affects time, causing clocks in regions with different gravitational strengths to tick at varying rates. For instance, a clock in the emptiness of space would run faster than one within a galaxy. These time differences could lead to the perception of an accelerating universe without invoking dark energy. Professor Wiltshire explains, "Our findings show that we do not need dark energy to explain why the universe appears to expand at an accelerating rate." He suggests that what we've been interpreting as dark energy might actually be variations in the kinetic energy of expansion, influenced by the universe's lumpy structure. This perspective also offers insights into the Hubble tension, the discrepancy between the current expansion rate of the universe and predictions based on early universe observations. By accounting for regional variations in expansion, the timescape model could bridge this gap. While these findings are compelling, they don't entirely dismiss the existence of dark energy. Instead, they encourage a reevaluation of our cosmological models and highlight the importance of considering the universe's complex structure in our calculations. As we continue to explore these cosmic mysteries, each discovery brings us closer to understanding the true nature of our universe. It's a thrilling reminder of how much there is yet to learn. Finally today, let's revisit a classic debate. What really caused the extinction of the dinosaurs? For decades, scientists have pondered whether massive volcanic eruptions or a catastrophic meteorite impact led to the dinosaurs' demise. Recent research from Utrecht University and the University of Manchester sheds new light on this mystery. The study focuses on the Deccan Traps in India, where colossal volcanic eruptions occurred around 66 million years ago. These eruptions released vast amounts of sulfur and carbon dioxide, potentially altering the global climate. By analyzing fossil molecules from ancient peats in the United States, scientists reconstructed air temperatures during this period. They discovered that a significant volcanic eruption about 30,000 years before the meteorite impact caused a global cooling of approximately 5 degrees Celsius. However, temperatures rebounded 20,000 years before the impact, likely due to volcanic CO2 emissions. This timeline suggests that while these volcanic events had drastic consequences for life on Earth, their climatic effects had dissipated thousands of years before the Chicxulub meteorite struck. Therefore, the meteorite impact remains the primary culprit behind the mass extinction event that wiped out the dinosaurs. Lauren O'Connor of Utrecht University notes, "These volcanic eruptions and associated CO2 and sulfur releases would have had drastic consequences for life on Earth. But these events occurred millennia before the meteorite impact and probably played only a small part in the extinction of dinosaurs." This research underscores the catastrophic impact of the Chicxulub meteorite, which unleashed wildfires, earthquakes, tsunamis, and an impact winter that blocked sunlight and devastated ecosystems. Understanding these events helps us piece together Earth's complex history and the factors that have shaped life on our planet. It's a fascinating reminder of the dynamic forces at play over geological timescales. And that wraps up today's fascinating journey through space, from Earth-orbiting satellite breakups to SpaceX's ambitious rideshare mission and the dramatic spring spectacle unfolding on Mars. I'm Anna, and I hope you've enjoyed this episode of Astronomy Daily. If you're hungry for more space content, I've got great news for you. Head over to astronomydaily.io, where you can sign up for our free daily newsletter and stay up to date with all the latest space and astronomy news through our constantly updating newsfeed. While you're there, you can also catch up on all our previous episodes. Want to join our community of space enthusiasts? You can find us across social media. Just search for Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. We'd love to hear your thoughts on today's stories and engage with you about all things space. Thank you for spending time with us today exploring the wonders of space. Until next time, keep looking up and stay curious about our cosmic neighborhood.